Hi everyone, and welcome to today's video on double displacement reactions. Double displacement reactions are the fifth and last type of reaction that we will be studying here, and so let's get started to see what happens. A double displacement reaction occurs when two ionic compounds in aqueous solution exchange ion partners. And so the format that I have looks like this. I have AC plus BD gives me AD and BC. And so the thing to remember here is that these are compounds. I don't have any free elements showing up in double displacement reactions. But the thing to notice on your product side is that essentially your ions have switched places with each other. The thing that happens in real life is that usually one of the products becomes insoluble. And insoluble means it doesn't dissolve in water and it forms a solid precipitate. The other product stays soluble, which means it's dissolved in water. If both products are soluble, then essentially there is no reaction and all the ions stay dissolved. And how I can tell if my products are going to be soluble or insoluble is to use the solubility rules. And you have received a handout of this to help us today. And this, again, only applies to the products. The solubility rules are only for the products in the double displacement reaction. It is important to note that only the positive ions combine with the negative ions. So it is kind of prescribed for me that A can only combine with D, because A and B would both be positively charged, so they wouldn't form the new compound. You can have AD and BC switched around up here. That's just fine. Like the order that these come in doesn't matter, but it does really need to be A coming before D and then B coming before C. Okay? And the other thing we'll pay attention to here is our ion charges when we make new formulas. So let's do an example. Here's a word problem, and I have silver nitrate reacting with sodium chloride to form silver chloride and sodium nitrate. So right now I just want to get my charges in there because all of these are going to be compounds, and then I'll use my solubility rules to figure out which one of the products is going to be a precipitate. So silver we know is always a +1 and nitrate is a -1, and so that formula is AgNO3. In your double displacement reactions, all of your reactants are going to start as aqueous solutions. So that's going to react with sodium chloride. Sodium is a +1 and chloride is a -1, so I have NaCl. And it tells me what they form. It forms silver chloride and sodium nitrate. Again, silver is a +1 and chloride's a -1, so I have AgCl. I'm going to leave the state of matter off for right now, and I'll use my solubility rules to look it up. And then I have sodium nitrate. Sodium is a +1 and nitrate is a -1. Okay, so let's use our solubility rules to figure out which one is going to be your solid. So right here, the very first rule, this is probably the most important rule and the one that you most likely need to have memorized. The other ones, I mean, there'll be more information for you. But right now it's a tool. You're just getting used to it, so we'll look it up for right now. This tells me that group 1 is always soluble. So anything that's paired with group 1 is going to be dissolved in water. So one of my products here has something from group 1 in it. Sodium is in group 1. So it doesn't matter what it's paired with, this compound is going to be dissolved in water. So I know that sodium nitrate is going to be aqueous. Okay, now don't use process of elimination and automatically assume that silver chloride is your solid, because it might not be. But let's look it up on your solubility rules just to be sure. The second rule down talks about chlorides, and it tells me that chlorides are soluble except for these three: silver chloride, mercury chloride, and lead chloride. Silver chloride was one of the products that I just made, and so it's an exception to this rule, which means it will be insoluble. I will put an S next to the AgCl. And now you want to make sure that you're remembering what these symbols mean. This is telling you the state of matter, right? So the S means that AgCl is a solid, which means it's insoluble. Okay, there's going to be a lot of S's that are showing up, so make sure that you're keeping those straight. This is telling me that silver chloride is going to precipitate out of your solution. So everything's balanced, it's all in a 1-to-1 ratio, and I have my states of matter in there. Okay, so let's do another example, and this time I don't have my products formed. Lead 2 nitrate reacts with sodium iodide. So lead 2 nitrate means that lead is a +2 and nitrate is a -1. And so my formula here is PbNO3 and again that's going to start out as aqueous. That's going to react with sodium iodide. Sodium is a +1 and iodide is a -1, so I get NaI. Okay, now right now you're going to want to go in and assign your letters from up here so that you really know what is going to switch places. So I'll just put in my letters kind of small up here. Lead was an A, which means nitrate is the C, and sodium is my B, and iodine is my D. So then on my product side, I want A and D coming together, and B and C coming together. So this is going to be helpful to you as well. If you just write down the charges as you write your formulas, then it's going to be really easy to just put the two new ions together that you need to. So lead was our A, and lead was a +2. It's going to form with D, which was I-. So I have PbI2, and I'll leave the state of matter off. I'll look up my solubility rules. Forming with, another product is BC. So B was Na+, and C was nitrate with a minus. So I have NaNO3. Okay, so I see NaNO3 again, which we just did in the previous example. And anything with sodium in it is going to be soluble. That's rule number 1 on our sheet here. So group 1 is always soluble. So it's a pretty safe bet that that is going to be aqueous. But again, let's just double check the lead iodide. I can't just automatically assume it's going to be a solid. Right here, close to the top, it tells me that iodides are soluble except for these 4. Silver iodide, mercury iodide, both forms, and lead iodide. Lead iodide was one of the products that I made, which tells me it's going to be insoluble. So lead iodide is going to be my solid precipitate. Okay? Let's try another one here with predicting your products, and this time we have just all formulas. So I'm going to write my letters, my A, my B, my C, my D, above it, and the ions right below it. So this was my A, and that's my C. This is B, and that's D. So I want A and D coming together, and B and C coming together on my product side. So then let's write down your charges. Calcium is going to be a +2, and chloride is a -1. Sodium is a +1, and hydroxide is a -1. You might not need to do this every time, but for right now it's just a strategy for you to remember your charges and to make sure they're getting paired up into your correct formulas. So A and D are going to come together. A was calcium and D was hydroxide. So I have CaOH2 plus B and C, so Na and Cl. Okay, I see something with sodium show up again. You're going to see this one pop up a lot, and so you should just start recognizing that anything with sodium is going to be dissolved in water. So NaCl, that's going to be aqueous. But now again, let's just double check my calcium hydroxide. Hydroxides are close to the bottom here on number 7. So it tells me metallic oxides are insoluble, except for these combinations. Group 2 from calcium down. And so calcium paired with hydroxide means that it's going to be an exception, which means it's not going to be insoluble, it's going to be soluble. So this is aqueous. Both products here are aqueous, which means all of the ions are still dissolved in water. There is no precipitate that forms. And that's okay. We're just doing this on paper right now, and you're just getting to recognize that there is no reaction that's going to happen. But for right now, just write the formulas for your products, including the states of matter, and so that you know that they're all dissolved in water. They're all going to be aqueous. And so the reason that we knew that was from our solubility rules. Okay, so you might run across a reaction like this every now and then. Most of the time, though, you'll end up with a solid precipitate that forms. Okay, so go ahead and try these just on the bottom. These are just formulas for compounds. Pretend they're products that show up in double displacement reactions, and just use your solubility rules and find out if they're going to be soluble or insoluble. And you can just go ahead and write that in parentheses next to it. The next page on your study guide has some more examples for you to work through with predicting the states of matter and correctly predicting your products for double displacement reactions. So give those a try. Write down any questions you have, as well as a summary of what you learned today, and we'll see you back in class tomorrow. Okay? Bye, guys.